Let's start with understanding everything this balanced equation tells us. This balanced equation tells me that 6 moles of lithium react with 1 mole of nitrogen to produce 2 moles of lithium nitride. Since we know that 1 mole of any material is equal to its molar mass, we can also calculate how many grams that would be. So if we need 6 moles of lithium, then this recipe is telling us that we need 6 times the molar mass of lithium, which means that we would need 41.65 grams of lithium. Since we need 1 mole of nitrogen, I can look on the periodic table and see that nitrogen has a mass of 14.01, so N2 would have a molar mass of 28.02 grams. So 1 mole would be 28.02 grams. It also tells me that I need 2 moles of lithium nitride. So again, I can look on the periodic table and calculate the molar mass of lithium nitride and multiply it by 2. And then that tells me that the recipe will make 69.66 grams of lithium nitride. So the equation tells us how many moles we need, and we can calculate how many grams that would be. We could also calculate how many liters we would need, because we also know that 1 mole of any material equals 22.4 liters. We also could calculate how many molecules that would be, because we know that 1 mole is 6.02 times 10 to the 23rd molecules. So again, if we need 6 moles of lithium, then we would need 6 times 22.4 liters to find out how many liters we need. Since we only need 1 mole of N2, that would mean that we need 22.4 liters. We could calculate our liters of lithium nitride by doing 2 times the 22.4 liters, and that means that if we need to know about liters, we would have 44.8 liters that are needed of lithium nitride. So there's actually a lot of information that's given to us and that we can figure out about our recipe that we could use. So keep all of this in mind as I work through the next problems. So if you're struggling with using the conversion factor method, let me show you another method for solving these problems. First thing is to look at the balanced equation and realize the things that it tells you. The balanced equation here says 1 mole of nitrogen plus 3 moles of hydrogen will produce 2 moles of ammonia. The next thing to keep in mind is that this also tells you the number of grams of nitrogen because you know the molar mass of each of these materials. By looking at the periodic table, 1 mole of nitrogen weighs 28.02 grams. 3 moles of hydrogen, 1 mole of hydrogen weighs 2.02, so 3 moles of hydrogen would weigh 6.06 grams. And then 2 moles of NH3, well, the molar mass of NH3 is 17.04, so we would multiply by 2 to get 34.08 grams. So this equation tells us 1 mole of nitrogen reacts with 3 moles of hydrogen, or 28.02 grams of nitrogen react with 6.06 grams of hydrogen. And that will produce 2 moles of NH3, or 34.08 grams of NH3. Now, we won't have to find the molar mass of everything for every problem, just the things that we are given and what we need to find. So let's identify what we're given, which is 25 grams of nitrogen. So we know we're going to be using this information from our balanced equation, and we want to find our grams of NH3. So we know we're going to be using this information from our balanced equation. So I didn't really need anything for hydrogen in order to solve this problem. I won't need any of this information here. So to solve this problem, all I need to do is put what I'm given on the top, which is 25 grams of nitrogen. put what I want to find on the bottom, X grams of NH3. That's what I don't know. I'm going to set that equal to everything I know about nitrogen. According to my balanced equation, 1 mole of nitrogen is going to be 28.02 grams of nitrogen. Well, since I'm given grams of nitrogen, then on the top, I can just use the grams of nitrogen that it says I need in my balanced equation, which is 28.02 grams of it. On the bottom, I have grams of NH3. So I can look at my balanced equation and I can see that my grams of NH3, I'm going to need 34.08 because remember, 2 moles of it are reacting. So I don't just need 17.04, I need 34.08 for this reaction to occur. Now that I have everything set up, I can solve for X. Remember that to solve for X in a problem like this, we're going to need to cross multiply. So we're going to multiply 28.02 times X, and then we're going to cross multiply 25 times 34.08. So that gives me that 28.02x equals 852. I want to solve for my x, so I'm going to divide both sides by 28.02. And so I find that x equals 30.41. Well, x was grams of NH3. So I'm going to go ahead and label that. And I'm done. Let's take a look at the next problem. The next problem, I'm given molecules of N2. So that means I need to know about this material here. The equation tells me that 1 mole of N2 is going to react. Well, we know 1 mole of N2 is 6.02 times 10 to the 23rd molecules. I'm writing that down because that's the piece of information I'm given about what I'm starting with. I'm starting with molecules. So I'm going to need to know how many molecules I need according to the balanced equation. So since the balanced equation says 1 mole, that means according to the balanced equation, I need 6.02 times 10 to the 23rd molecules of that material. Now let's find what we need to figure out. It's asking for molecules of NH3. So NH3 is over here. According to my equation, it says that I need 2 moles of NH3. Well, let's see. 2 moles of NH3 would be 2 times 6.02 times 10 to the 23rd molecules. Again, I'm finding out how many molecules because that's what the problem is asking me for. So if I do 2 times 6.02, then according to this equation, I'm going to need 1.204 times 10 to the 24th molecules, because that's what 2 times 6.02 times 10 to the 23rd is. So 2 moles, or 1.204 times 10 to the 24th molecules. So now I can set up my problem. I'm given 5.6 times 10 to the 25th molecules of N2. I want to find out how many molecules of NH3 I need. Well, according to my equation, I need 6.02 times 10 to the 23rd molecules of N2, and I need 1.204 times 10 to the 24th molecules of NH3. Now, all I need to do is cross multiply and solve. So I'm going to first do x times 6.02 times 10 to the 23rd. So 6.02 times 10 to the 23rd x is equal to, my next step is going to be cross multiply 5.6 times 10 to the 25th power times 1.204 times 10 to the 24th power. When I multiply my right side, I get 6.74 times 10 to the 49th. To isolate my x, I need to divide both sides by 6.02 times 10 to the 23rd power. So that X is going to tell me my molecules of NH3. So my answer is 1.12 times 10 to the 26 molecules of NH3. So the basic idea for solving these problems is to put your given material and the units on the top and put the material you want and the units on the bottom. Then you can set that equal to the material and units that you're given, and you look at the information in your balanced equation. So you have to look at that. And then on the bottom, you put your material and your units that you want from the balanced equation, the information from the balanced equation. So if I were to give you 2 grams of CO2 and I want to find how many grams of H2O that would be, I can set that up on my left side of my balanced equation. So it would look like this: 2 grams of carbon dioxide over X grams of water. Now I need to find out my information from the balanced equation. Well, I want to know how many grams of carbon dioxide the balanced equation tells me I need, because that's what I'm starting with on top. And I need to find out how many grams of water the balanced equation tells me that I'm going to need. So if I look at carbon dioxide, I need 6 moles of it. So to find my grams, I need to do 6 times the molar mass of carbon dioxide, which is 6 times 44.011 grams. That's going to tell me my grams of carbon dioxide from my balanced equation. Next, I look at water. Since water says also I need 6 moles of it, I'm going to have to do 6 times the molar mass of water to find out how many grams my balanced equation says that I need. So I need 108.12 grams. So remember that your information on the right side gets calculated from your balanced equation. And to solve this, I simply cross multiply and solve for X. And when I do that, I get 0.82 grams of water. Let's try a few more problems, and feel free to pause before I give the answers so that you can see if you can do them on your own. First, identify what you're given: 12.66 grams of gallium. So that means I need to know about this piece of my recipe. Then identify what you need to find. I need to find my moles of gallium iodide, which is going to be this piece here. So let's look at this recipe and see what we know. According to the recipe, we know that we're going to need 2 moles of gallium. Well, let's find out how many grams of gallium that would be. So we're going to need the molar mass of gallium. The molar mass of gallium is 69.72. But since I need 2 moles of it, that means that this recipe actually requires 139.44 grams in it. So my recipe tells me 2 moles of gallium and 139.44 grams of gallium. Let's also see what we know about gallium iodide. 2 moles of gallium iodide are going to be going in, or if I need grams, then my grams of gallium iodide, I could calculate my molar mass, but I'm going to notice up here that it's asking me for moles. So I actually don't need to know anything about grams of gallium iodide because I already know from the balanced equation that it's going to be 2 moles of gallium iodide. So we start the problem by putting what we're given on top. We're given 12.66 grams of gallium. On the bottom, we're going to put our unknown, X moles of gallium iodide, because that's what we want to solve for. On the other side of the ratio, we're going to put the grams of gallium on the top that the recipe tells us. And the reason we're doing grams and not moles is because we're given grams. So according to the recipe, it's going to be 139.44 grams of gallium are needed. On the bottom, I'm being asked for moles. So I only need to use from my recipe the moles information. So the recipe tells me that it's 2 moles of gallium iodide that are going to be reacting. So the left side is everything I'm given and what I need to find. The right side is the information from my balanced equation. So if I cross multiply these to solve, I'm going to do 12.66 times 2, and then I'm going to set that equal to my 139.44x, because we're going to multiply this times this. We're going to cross multiply. So this is what our mathematical algebra should look like. I'm going to solve for my x by dividing both sides by 139.44, and x is going to tell us our moles of gallium iodide, because that's our unit here that we're solving for x. So my answer comes out as 0.18 moles of gallium iodide. If you want, take a minute and pause and try and do the next problem on your own before I go over it. So I've started with identifying what I'm given and what I need to find. I know from my balanced equation that I have 3 moles of hydrogen reacting. And since I'm starting with grams of hydrogen, I know I need to know how many grams that would be. So I'm going to take 3 times the molar mass of hydrogen so that I can find that that means that this equation tells me I need 606 grams of it because I need 3 moles of it. I'm going to notice that for my ammonia, that it's just asking me for moles. So if I look, the equation tells me 2 moles of ammonia. So I have all the information that I need to start. I'm given 4.25 grams of hydrogen. I want to find out how many moles of ammonia that is. So everything I know about hydrogen goes on the top. Since I am given grams of hydrogen, I want my grams of hydrogen from the recipe on the top. So 6.06 grams of hydrogen. On the bottom, I'm being asked about moles. So I'm going to put on the bottom my moles from the recipe that I know about ammonium. Now I can cross multiply and solve for my x. So 4.25 times 2 is going to be 8.5. So then I'm going to divide each side by the 6.06 to solve for my x. So I get 1.4, and then I add what my units are from my equation. Moles of NH3 is what I just found. Here's one last practice problem, a little bit different. This one is giving me 75 grams of nitrogen. So here's my nitrogen, and it's asking me how many liters of NH3. So let's see what our equation tells us. In terms of grams of N2, we know according to the equation 1 mole of N2. So for our grams of N2, we're going to need that since we're given grams of N2. The molar mass of N2 is going to be 28.02 grams. In terms of liters of NH3, our balanced equation tells us 2 moles of NH3 are necessary. Well, 1 mole is 22.4 liters. So 2 times 22.4 liters, since we need 2 moles, would be 44.8 liters. So our information that we know is here. So if we set up our problem, we put what we're given on the top, grams of N2. We put what we want to find, liters of NH3 on the bottom. Then we use our information from our balanced equation and the information we know. We know how many grams of N2 we're going to be needing. According to our balanced equation, it's 28.02 because that would be the mass of 1 mole of N2. We want to find liters. Well, according to our balanced equation, we need 2 moles of NH3, which would be 44.8 liters. So we're going to put 44.8 liters of NH3 on the bottom. Remember, this information here is going to come from our balanced equation. Now we can simply cross multiply in order to solve for our answer. So if we cross multiply and solve for x, you should get 119.9 liters of NH3. If we're given a problem where we are given moles of C3H8 and we need to find moles of a different material, these problems are very easy to solve because remember, the balanced equation tells us the moles. According to my balanced equation, I need 1 mole of C3H8 and 5 moles of oxygen. So I'm going to set my problem up with what I'm given on the top and what I want to find, my unknown, on the bottom. I use my information from my balanced equation to tell me, well, how many moles of C3H8 do I need? According to my balanced equation, I need 1 mole. And then, since I want to find moles of oxygen, I'm going to look at my balanced equation and find out how many moles of oxygen does it say I'm going to need. It says I need 5. To solve this problem, I simply cross multiply and solve for my x. So you should get x equals 20 moles of oxygen. What about a problem like this, where we are given our grams of aluminum oxide, but we need to find something different, like number of molecules of oxygen gas? Well, the thing to keep in mind is always put on the top what you're given. I'm given 13.3 grams of aluminum oxide. Always put on the bottom what we want to find. We want to find our molecules of oxygen gas. So now let's see what the equation tells us in terms of grams and molecules. Well, I want to know about grams of aluminum oxide, which is going to be this material here. So according to my equation, it tells me that I need 2 moles of aluminum oxide. So I'm going to need 2 times the molar mass of aluminum oxide to find out how many grams of aluminum oxide this recipe is calling for. So according to the molar mass, which is 101.96, since I need 2 moles of it, that means that my equation tells me I need 203.92 grams of aluminum oxide. Now let's see about molecules of oxygen. Well, my balanced equation tells me that I need 3 molecules of oxygen, or 3 moles of oxygen. So we know 1 mole is 6.02 times 10 to the 23rd. So if I need 3 moles, I'm going to have to multiply that times 6.02 times 10 to the 23rd. So that tells me that I need 1.81 times 10 to the 24th molecules of oxygen. And I did that because I want to find molecules of oxygen. So to solve this problem, we simply again do our cross multiply and solve for x. And so you can see my work, and my answer is 1.18 molecules times 10 to the 23rd molecules of oxygen.